G'day, Lance from Motive Power. Back today to talk about another aspect of special vehicle design. This time, electrics and electronics. Not so much a technical discussion, but more about the things you should consider in designing such systems for your vehicles. So I'll admit today's session is probably more a rant than an actual technical discussion. I'm a mechanical engineer. A lot of electrical stuff is just nonsensical. DC, not too bad. I just consider it as hydraulics down a pipe. But AC, beyond me. I want to remind you from a terminology point of view that anything electrical, we'll be talking about motors, not engines. We talked on a previous video and explained that engines were thermodynamic devices, motors were non-thermodynamic, non-heat engine devices. So if it's an electric motor, that's the right term. And I guess that's a segue into motor cars. They're called motor cars because back in the 1880s, when electric cars were first created, they were the first cars. So they were called motor cars because they had electric motors. Now, unfortunately, that moniker has stuck. We need to drop the motor part of it and just talk about cars now. And that's where the confusion between what's under the bonnet comes in, whether it's an electric motor or an internal combustion engine. So way back, electric vehicles are not new. There's a lot of hype about them now, mainly because two things have happened in that time. The control systems for electrics have got a lot better, and the batteries have got a lot better, but only in recent times. They're the two game changers, but they've been around for a long, long time. In mining, they are the preferred type of vehicle, and I'll show you some examples here. So this is a Komatsu loader, their biggest one. It is in fact a Letourneau, Komatsu having bought out Letourneau. R.G. Letourneau was an American engineer, very big in the 50s, did an amazing array of crazy, weird, stupid vehicles, but he was fascinated by electrics, and hence everything was electrics. No hydraulics until very late in his career, when frankly the electrical drives got a little bit out of control. So this is an example of an inherent design that's 70 years old and still going strong. Diesel electric, diesel driving a generator, and hub motors. So this is the preferred big loader in mining and well established. Of course, what do you load? Well, as an example, here's Caterpillar's big mining truck, their biggest, 372 ton capacity, weighing in at over 623 ton gross vehicle mass. Big beast. Now, it's also diesel electric with an alternator and hub motors. So, you know, this stuff has been around for a long time. My first job out of uni 40 plus years ago was designing haul trucks for Wabco. And at that time, the big push was to get away from hub motors and go mechanical, because they were seen as more reliable mechanical drives. These days, it's flipped, and electrics are more reliable and available in larger sizes than mechanical can cope. So the current fascination with battery electric vehicles is interesting, but it's about 70 years late. The technology is only catching up with where it should have been. Battery vehicles in off-highway, there's certainly no reason they can't be used, and they're becoming more and more used in construction, but they do have some limitations. Particularly, what do you do with a dead battery? A vehicle with a dead battery that's just stopped. There are some applications where there is just no easy fix to that. But sometimes they're actually a really good solution. And I've seen recently people replacing hydraulic cylinders with electric actuators. And that can be a really simple, quick, and easy solution to your problem. In fact, Bobcat have gone one further, perhaps two further. Let's have a look at them. So this is Bobcat's new T7X. It's an all-electric machine. There are no hydraulics on it at all. All the functions are electrical, including the boom lift. They've gone one further step with their new Rogue X. No cab, remote control, heading towards autonomy. And this is again a great reason to have all electrics. It just makes things easier. Not a bad looking machine. They've styled it quite nicely. So driving vehicles. Theoretically, electrics is a better solution, particularly in bigger and bigger sizes. You do get to the point where a mechanical transmission just can't handle the power. And if you want a distributed power, then electrics is the only choice. You still need to be careful of things like a differential action and controlling wheel spin and so forth, but that can all be done. Now, much of my work has been in underground coal mines, a hazardous environment where the air you breathe is explosive, and the surfaces that you're touching around you are also explosive. In that environment, electrics are used, and they're used for the same reason I just mentioned. High power. It's just very difficult to get mechanical, i.e. let's say diesel, in high powers into confined spaces and ventilate it properly. It can be done, but mining machines tend to be 1,000-volt trailing cable. Smaller vehicles typically are diesel powered because they're not actually at the face. They're, I guess, flitting around doing various jobs and in better ventilation. Electrics can be used in those situations and are used in those situations, but they're complex, they're expensive, and they need continuing maintenance. It all comes down to what's called explosion-proof equipment. So you're containing within an electrical enclosure the flame. You can, if gas gets in and ignites, it won't let a flame come out. So that's tricky to do. It's also tricky to do for things like sensors, because you have to limit the amount of power going to and from those sensors, so it's impossible for them to create a spark. So generally in those environments, the use of electrics is limited because of cost and complexity, but they are used where needed. For battery electric vehicles in those conditions, they're rare. Certainly in underground coal, still used a little bit more in hard rock, but one of them, probably two reasons, if not three problems with battery electric vehicles underground. What do you do with a flat battery, a vehicle with a flat battery? You can't plug in another battery because that's a potential sparking situation. You can't readily tow things back in an underground coal mine. You just don't have the space and the turning ability. And the batteries need to be in a special ventilated and managed area for safety reasons, particularly if they're giving off gases. But it's a different situation now with surface applications, because things are a lot easier there. You can now buy complete electrical systems from a range of suppliers. And my list here, and it's only a quick list: Mahler, Bosch, Dana, GKN and Liebherr. They'll all sell you electrical drivetrain components. Wonderful. You can probably get a whole package. You might still have to worry about how you cool your batteries and so forth, but the chances are you can buy the majority of the parts already proven. Now, you can just add an electric motor to an existing mechanical drivetrain. That's great. Nothing wrong with that, but you probably won't get the full advantage of having a full electric drive and hub motors. So now we get to the lived experience. Don't put too much reliance in electrics, and particularly in electronics. I helped a client recently who'd done an electric man carrier for underground coal mines, and he'd done a really good job. Particular thing to review, however, was the brakes. They were mechanical brakes, hydraulic brakes, the normal sort of thing you'd see on your car. But he'd put the parking brake through the computer. It was a switch. And from functional safety point of view, and making it fail safe, we now had to worry about the reliability of the switch, the reliability of all the electrical hardware that was involved, the reliability of the software, the vulnerability to glitches. It would have been so much easier just to make a mechanical park brake, and inherently much safer. I've also had situations delivering aircraft towing tractors around the world. We were warned, particularly in one Asian airport, that our competitors were paying mechanics to disconnect the battery leads, swap them over, zap the electronics, put the leads back where they were, so that the non-preferred supplier had a continuing problem with onboard computers frying. So we put some diodes in, we never had a problem, but that's a good lesson for your systems and for your functionality of your design. Make sure nobody can stuff it up easily, and certainly put reverse polarity protection into your systems. Electronics aren't always easy on vehicles. I know lots of cars and so forth have extensive electronics now, but there are issues on bigger vehicles. One of those big aircraft towing tractors was made of 80mm plate, and we thought for sure that's going to make a great earth. That's one heck of a conductor. But we couldn't get the speedo to work. We'd feed it with a signal generator with the right signal and it would work fine. We'd put a crow on the sender and it was the right signal. Connect the two together, speedo wouldn't work. Because of the distance involved, there was just a 0.5 volt difference in the earth, and that was enough for the square wave to be shuffled down so it wasn't registering on the speedo. We had to run an extra special earth, which seemed crazy when you have a conductor that's 80mm thick and 3 meters odd wide. But it does happen. Simple electrical circuits are a fact of life. It's very difficult to put headlights on a car without using electrics. It is possible, they used to do it, but it's not something we'd want to live with now. Electronic systems are fantastic when they work. When they don't work, it's just another troublesome computer and you can't fix it yourself. You have to go and get an expert. If you think back to those Bobcat examples, it's not going to be an easy problem on those. Every time you're going to be calling out the Bobcat tech to plug in his reader and see what's the problem. Electronics and electrics are great. I'd counsel you to just use them where you have to, where it makes sense. If there's a mechanical way of doing it, go the mechanical way. It's easy, it's trouble-free, it's easily fixed, it's easily understood by operators, perhaps in different cultures and languages. Do not, above all, do not put an electrical or electronic solution to a mechanical problem. I've seen it done. It's causing a lot of pain at the moment for one of my OEMs. So work out what you really need. Forget the rest, particularly if the sexy bits, things you don't need, and watch your programming. I had a client I helped with B doubles. He was unloading the B double and he wanted to straighten it up. So he drove back out across a main highway to straighten it up so he could back it in easier. As he drove it out across that highway, a balk of timber fell off the trailer and sheared off the terminal on the fuel sender on the fuel tank. Truck stopped. That's the way it was programmed. There was no reason for the vehicle to shut down because it didn't know how much fuel was in the tank. That was an unnecessary bit of programming, caused a major bit of grief with a blocked highway. Don't fall into those sort of traps. Think very carefully about what you need. Forget about sexy bits. They're not worth the trouble. Get your electrical system simple, straightforward, and easy to maintain in the location it's going to work. And then you can comfortably move on to the rest of the design.